Capture filter is telling Wireshark what to capture from those traffics that are coming. See, you may be having millions of packets coming in, but you are telling Wireshark not to capture everything, but to capture only particular type of packet, which is capture filter. Whereas display filter is Wireshark captures everything, and for you to see what exactly you want to see, you put some filter on the top. That is display filter. So when you have capture filter, you you don't see too many things. See, this is what called as display filter. This is where we stop. It's what called as display filter. Here, if I say you need to you need to capture only the TCP port TCP, or right now we are doing voice call, right? I'm saying show me all the UDP packets. So only the UDP packets it is going to capture. Wait, I think I have to mention the interface. I forgot to properly select the interface. You need to select the interface first. Wi-Fi interface. In Wi-Fi interface, I want to capture only UDP traffic, no other traffic. So only the UDP. See, these are all UDP packets. Even RTCP is also UDP. It uses UDP. You see, this uses UDP. Real-time protocol is a voice protocol. It uses UDP. Real-time transport control protocol uses UDP. So you can't see any TCP packet. See, if I search, show me TCP packet, none, because you did not capture. So the problem with the capture filter is, if you're doing this capture for troubleshooting, what if UDP is not showing you the real trouble? You said show me only UDP packet to troubleshoot, but the trouble, the error, the cause of the trouble is not shown in UDP packet. It is shown in some other packet. Maybe keep alive, retransmit, some TCP, some ICMP. How will you know there are trouble now? You will not know. So for troubleshooting, capture filter is not good. Instead, wait, you you capture all that enters into the interface, and then put the display filter. See, I say whatever comes inside this Wi-Fi, show me. And now I can say, show me only those TCP packets. At least some TCP packet will come if I start surfing some web page, www.facebook.com. Definitely, I should see some TCP packet now. Go to the sniffer. Look at this, the TLS TCP packets. Because I generated some traffic by starting the web page, which uses HTTPS. You see, 443. HTTP is what today called as TLS. All right. Earlier we used to call this hyper HTTPS hypertext HTTPS hypertext transmission control protocol, something like that. So now we have TLS, transport layer security. We also have DTLS, which is another flavor of TLS. Uh, this is TLS. So using the display filter is better than doing capture filter. You just put whatever you want to display. So some commonly used display filters I'm going to show you now. If you want to display the packets that are uh, coming from, means it's a source. If you want to see all the packets that are coming from, wait, let me stop the capture. I stopped it. See, I want to see the packet that is coming from 142. This one. Right now it is a destination. I don't want destination. Say this is coming from source. I can simply type IP dot src equals 142.250.82.4. It shows all the packet that comes from this particular IP address. And how many packets? Out of 23,000 packets, 7,657. You see here displayed. They are coming from this particular IP address. Now, if you want to see all the packet coming from the subnet, not the IP address, you want to see from the subnet, you just put 0 and then put the mask. Whatever the mask that you want to say. Now, how many packets? Is it the same number or different? So this is for matching the subnet, first 3 octets. Or let me say /16. So first 2 octet. Now you see more number of packets. Earlier it was 7,000, now it is 8,159. More number of packets because I'm matching only the first 2 octets. This is to match the source subnet. Earlier we saw match the source IP. And next, I want to see what all packet that goes to 192.168. So I'm saying all the packet that has got destination instead of the source. Show me all the packet that has got source IP address 192.168.1.63. See, this is actually my laptop's IP address. Now my laptop has generated these many packets. Out of 23 packets, around 14,842 was initiated by my laptop. 62.2% of traffic were initiated by my laptop. I can see that here. And it's really a fast communication. You see the server which is responding is UDP, no? So the time taken, you see, millisecond, 001 millisecond, 006 millisecond. Oh, it's really very fast. Now, if I want to see all the packet that has got TCP 443, then I'll say TCP dot port equals 443. It will display only those packets that has got TCP 443 as a port number. Around 1,530 TCP packet which has got the port number as 443. What if I want this to be only a source port number? Then you need to say TCP source. Source port equal to 443. So out of 1000 change, it is only 588 packet sourcing TCP that has got 443 as a source. So definitely they are not from us, they are coming from outside. These are all coming from outside because we are not a web server. My laptop is not a web server. So there is no chance for, you see, I'm going to say, show me all the packet that has got this port number as a source as well as the IP source equals IP dot source. equals 192.168.1.63. I'm asking, show me those packet that that originates from here at the same time with this problem. No chance. You will not see any packet because I'm not a web server. I know my laptop is not a web server. Yeah. But if you remove that source port number, then you'll see majority of packet are from my laptop. Yeah, majority 14,852 packets are from my laptop. Now I'm going to pass on this particular file to you, and I'm going to ask you some question. You will be answering me. So let me save this. I'll save it as D5. I'll save it as personal class D4. This is to understand common filters, right? How many fin packets in this file? So the question is, who is the top talker and how many packets he has so far sent and received? That is the question. Wait, I'm trying to share my screen with you. Right, do you see my screen? Okay, so among this 23,897, first of all, you need to know how many conversations are going on. How many conversations? For that, you go to statistics and go to conversation and go to IPv4. These are the number of conversations. There are 31 conversations. 31 different members are communicating, different duplex. See, 192.168.1.63 source is same, but the destinations are not same. They're different. So in this, who is a top talker? Meaning, who is sending too many packets? For that, you just click on this packet. With this minimum, it shows. This is the maximum. So the top talker is no. I'm not okay with this. Wait, don't come to conversation. Better come to endpoints. That will give you the more accurate top talker. See, out of 31, the real top talker is 192.168.1.63 because it's me, my laptop. And it has sent so far 23,851 packets. This is the answer. Who is the top talker and how many packets he sent? The top talker is 192.168.1.63. Why I'm calling him top talker? Because he has sent 23,000 packets. Okay, next question. Now in this pcap file, how many TCP conversations are there? How many TCP conversations are there? How you got that answer? 1056. How many how many conversations, TCP conversations? Rashagir, you answer? What are the answers you have said so far? Arul, what is the answer you said? Who said 26? Who said 26? Very good. That's the right answer. That's the right answer. How do you get it? Yeah. Go to statistics. Arul. Statistics. Conversation. You see TCP tab, there it is written 26. All right. Now, how many R packets are there in this pickup? How many R packets are in this pickup? Ashir. 5 is the right answer. Did you get the same answer, Rashagir? Just no. Go to display filter and type ARP. That's all. Okay. Now, how many IP packets are there? How many IP packets are there? Or Arul, how many IP packets are there? What? It's almost 96 percentage are IP packet, right? Just type IP on the top. That's all. It is 99.8 percentage, like 23,800. Okay. In this, how many are layer 2 broadcast traffics? How many are layer 2 broadcast packets? Rashigir, no idea. Hmm. See, layer 2 broadcast address will be like what? How it will look like, layer 2 broadcast address. Okay. Search your destination, layer 2 address destination need to be FFFF. Search it. I'll give you a clue, okay? We have a cheat sheet. Did I show you about the cheat sheet? Go to analyze and click on display filter. Go to the tab analyze and click on display filter. There you will see some cheat sheet, some example, some filter expression. Ah, oh, that is what actually you need now. We want layer 2 broadcast. What is layer 2? Ethernet only. Analyze first tab. Click on the first one. Under the analyze, click on display filter. Ah, how many you get? Sorry, how many? Very good. See, only the difference between your answer, my answer is same, but I was searching in another way. But to help you only, I went to the cheat sheet. See, I was typing ethernet.dst. See my screen? Ethernet.dst destination is equal to FFFFF. All are same only. Okay, so it's my laptop. I'm sending a broadcast. Whether you search it as address or destination, it is going to be same. Okay, next question. I want to know how many packets are TCP HTTP 443. See, I don't want to simply know all TCP packets. No, I don't want all TCP packets. I want to know the packet that needs to be TCP as well as it needs to be HTTP 443. How you will find? No. We need a packet which needs to be HTTPS packet, means TLS packet. At the same time, it needs to be a TCP. TCP. If you simply type TCP, how many packets you get? 1056. And if I say 443, how many packets you get? 453, right? Sorry, 1053, isn't it? See, if you simply type TCP, it is 1056. But if you say no, in TCP, I want the packet which is equal to 443, then what you get is that's what I was asking. It needs to be a TCP as well as HTTPS or HTTP. It is understood that HTTPS. So it is 443. So how do you type that? TCP dot. 443 is the port number for TLS. When you click on TLS file, you see that 443 destination. Right, we checked conversations. Mm, Okay, now look into the board. We'll go back to the quiz later. Let me share my screen again. See, there are operators that we should know. Operators like equal to, we always use equal to. If you are using equal to, then you should have a space in between the before word and the next word, the filter words, filter operators. Or you can say ip.addr equals, there is no space needed, equals 10.0.0.1. But if you're putting this equal, then you should have a space, ip.add space 10.0.0.1. So very important. If you're using the alphabet, then you should leave space. If you're using the operator symbols, then no need space. Now this is the symbol for not. Okay, not, and then this is the symbol for or. You can type or you can put two pipe. You can put not, or you can put one exclamatory. You can put these two symbols and, or you can say and. You can say greater than like this, or you can say greater than like this. You can say less than like this, or you can say LT like this. Okay, so these are all the operators that we have. Now, shall I give you an exercise now based on this? I want to know how many packets are uh, TLVs. So wait a minute. How many packets are TLS? How many packets are TLS? At the same time, the source address need to be my laptop address, 192.168.1.63. Source address need to be this. At the same time, it needs to be a TLS packet, not R packet or not any other packet. It needs to be a TLS packet. How will you find? You can use any operator that you like. Tell me how many packets you will. You have. How many packets you have? It needs to be this IP address, and it also needs to be a TLS packet. 178 packet. Okay. Yeah, Rashid, do you have any other answer? Check. What is the answer you said, Rashid? Okay. Let me see. I said it needs to be port number 443, that is TLS, and huh? And IP dot, correct. Both are same. And source equals 192.168.1.63. 465. Is that you said? No, I'm getting this. Uh, TLS port number is 443 only. Wait, let me see. Why? Let me see. And you said and TLS, huh? Yeah, it shows only 178. You said 178, right? 178. Then what happened to the other traffics? When I say okay, when I say yeah, you're right. You're right. When I say port number 443, it also includes TCP three-way handshakes of TLS, which is TCP. See, when I say TCP dot port equals 443, you will see a lot of TCP packet also. You see TCP. This TCP packets also uses 443 because they are doing three-way handshake for this TLS only. So, but what you found is the right one because I was not asking TCP. I was very precisely saying it needs to be. Yeah, புரியல. How will you use R operator? Okay. Okay, give me an example. You can say this one and not not port dot TCP dot sorry not TCP and not TCP not TCP. Now I'll get what I was sorry Arul was telling. It should not be TCP, but it should be 443. No, it's even even TLS is TCP only, so I cannot say TCP. Like no, it won't work like this. Tell me, Rashir, what you were trying to say then. Okay, fine. I'll give you another example. Sorry, I'll give you another question. Show me all those packets which are not layer 2. Okay, let me put it in another word. Show only layer 3 packets. Layer 3 and about. I do not want to see any layer 2 packets. I don't want to see any layer 2 packets. See, this has got layer 2, layer 3 packets. Take out all the layer 2 packets and show only layer 3. See, if you put IP, you will get only layer 3. It's 23859. Or let us also find like this, we can also find like this. How, not ARP, um, wait, not ARP. I think I can keep more protocols inside. Not ARP, DHCP, CDP. These are all layer 2, okay? So I'm removing all of this. It won't work. I need to put separately. Not ARP and not DHCP and not CDP and not, you can also type English not LLDP. Boom. So how many number you get? It has reduced 5%. Means 97 is the overall number of packets. I get 92. So 5 packets got filtered. 5 packets were ARP, DHCP, or among them, or all of them. So this is how you can use the OR operation. Okay, we'll see more examples later. Now what we'll do is, okay, we already found the layer 2 broadcast packets. I think it was somewhere around 3 or something. Now you try to display all the other packets other than layer 2 broadcast packet. How will you display? Other than layer 2 broadcast, display all other packets. Let's see how many packets it comes. Other than layer 2 broadcast, display all other packets. How will you display other than layer 2 broadcast? Mhm. Not ETH dot address equals 2 times equals ff. Should I put dot ff dot ff? No, I think ff colon. Good. All right, that is right. We saw 3 packets, correct. It is 2,300 and sorry, 23,894 packets, which means correctly 3 packets are layer 2 bird. So it works. So you learned NOT operation. Okay. Now something which I'm going to show will not be possible for you because for you we need to install some Geolite in your laptop. You have not installed so far. See, in my laptop I can see the country from where these packets are coming. As I have already showed you in the previous class, I can see this is Bharti Airtel, Bengaluru. You see, I want to filter all those packets that are coming from India. How will I do it? See, when I click on this, I get here the filter. I say ip.geo ip.country equals in. In means India. It didn't work. In. So I'll type India. India. It didn't work. Capital IN. What? Surprise. Let me try again. Yeah. See, I need to put inside the parenthesis. All right. I put it inside the quotations. Parenthesis. India. Likewise, you can say city, Bangalore. All right. It very clearly shows the location from where I am. And if I go to statistics here and go to endpoint and click on the IPv4, so this is the Facebook. I have gone Mumbai, all in India only. Click on map and see. It's Mumbai and US. Maybe a copy is coming from US, but I have locally the copy of Google, copy of Facebook. All right. So when I click on Wireshark and see the countries, I see only India here. India, Bangalore. Organization Northeast Data Network Private Limited, Bharti Airtel, Facebook. These are the organizations. Let's see some live and then come back. Let me do capture again. Continue without saving. Wait, I should be getting more actually. I'll teach you in the next class. It will take time. So now, wait. Okay, now comes a lot of things. Microsoft, United States, Glencore. Let me try to open more pages. I'll open YouTube. I'll open www.yahoo.com. And now let's go and see from where all we are getting this. Statistics, endpoint, IPv4. Wow, too many. So Singapore, Japan, India, Singapore. Yeah, a lot of mirror copies in Singapore for Yahoo. Whenever you search Yahoo, you will always get Singapore. Google always uses Taiwan, Yahoo, Holding Limited. Hmm. So you can also go to map and see them. Especially the attacks, we can easily uh, come and see like this attack packets. We'll be doing an exercise to identify a DOS attack later days. We'll do it maybe in next class. Okay, so that's about GeoCity. GeoCity will come later because there are many more things to cover before that. I showed you how to save. Now we need to do a assignment, but I think I should take a leave now. We will continue this tomorrow.